Hello. All right, so in this video, I'm going to be going over example problems using the chain rule. So I'm going to start with like basic ones, medium ones, and some tedious, more complex ones. I'm not really going to be doing like the theory and the proof and like why it works or like what's going on the concepts and stuff because 'cause I don't want to, but also because it's really important that you first know how to use it because um, first off, because I'm a high school teacher and I know it's much easier to get the students to learn how to use it before trying to, explain the concept and all that. But I will still go over that in a different video, but this is not the video. So if you want to learn how to get good with the chain rule, here we go. So the chain rule basically says this. It says that if you have a function of a function, let's say you have a function y is a function as a function of a function or like a composite function. So there's a function within the function. I know I've said it like 20 times, but let's say if you want to find the derivative of y, you're going to need to take the derivative of f, leaving the g or inside part by itself, and then you're going to multiply it by g prime of x. Now, when I'm doing these examples, I really emphasize using like a different color. Like I'm not even like a note person that likes. I don't think I ever even use a highlighter. But well, I'm still not going to use a highlighter here. But what I mean is that if there's ever one time where you're going to be using more than one color in your notes, this is the time. Especially if you're a little confused with the chain rule, because the coloring really helps. So think of it like this: you have a function, the red function inside the black function, and if you want to find the derivative of this whole thing, like again, the whole thing. You gotta take the derivative of the black function, keep the inside the same, and then multiply by the derivative of the inside function, g of x, or g prime of x. So let's look at an example. So usually they'll use like something called u substitution, but that doesn't really matter. So let's go for example. We have, let's say y is the sine of x. No, the sine of 2x. And if you want to find dy dx, you see you have a function 2x in here, but the sine function is the outside, the one in black. So you want to take the derivative of the sine function, which is the cosine, and you keep all of that the same. Okay? Yeah? Then you multiply by the derivative of that red function. So the derivative of 2x is 2. And again, I use parentheses like crazy here because it's going to help you. So I would even use it like this. It's not the cosine of 4x, it's 2 times the cosine of 2x. So use the parentheses like crazy. Be like in love with them. Like, it's really gonna help. Well, at least, hold on, keep it looking at the wrong camera. It's really gonna help you like know what is what. So let's look at another example. So let's say we have. I'll call this A, I guess. Oh, whatever. I don't even know. Well, I started on. This is example A. I don't know why I'm taking a look at that. So example B. We have y equals the square root of 3x squared minus x plus 1. You see? Now this is the same as 3x squared minus x plus 1 to the 1/2 power, because that's the square root. Same thing. Now, what you have on the outside is the 1/2 or the square root function. But on the inside, you have this 3x squared minus x plus 1. So, I keep on looking at the wrong camera, but if you want to find y prime, you're going to take the derivative of the black function. And whenever you take the derivative of the outside function, you leave everything else the same. So it'll be 1/2 times the whole thing on the inside stays the same to the negative 1/2. You see? And then super parentheses. It may not be necessary here, but well, it's not, it's really sometimes, it's not ever really necessary, but it helps you see it and understand it better. But now we can multiply this whole thing by the red. So then we go and multiply by the derivative of 3x squared minus x plus 1, which is 6x minus 1. And that's really the main answer. Whoa, where'd it go? Here I am. This is really the main answer. Sometimes they'll want you to clean it up. I don't really care about that. Well, I care. Make it a little better than this. So in your textbook, you may see it as 6x minus 1 on top, and then a 2, and they're probably going to have this as a square root. Opposite. Yeah. Anything more than that is just like the professor, teacher trying to like show off and be like, oh, you got to factor that into rational. Oh, this is good enough for me. I hope it's good enough for you. All right, next one. It looks like I skipped C on my notes, so we're gonna go to D. D, we got y is the tangent squared of x. Now you see it's written like this usually in textbooks. But what this really is, let's put this in parentheses, this is the same as a tangent of x. Let's see, this whole thing is being squared. It's not like this took me a while to figure out what it was when I was first learning math. Long, like hundreds of years ago. And let me make the tangent function red. So the tangent function is on the inside, the squared function, second power function is on the outside. Because this is just like tangent of x times tangent of x. So technically you could use product rule if you want. But that's lame. That's for losers. Or math losers, I guess. The cool people are going to use the chain rule. So we're going to go y prime. We take the derivative of the power function, which is 2 times, we keep the whole tangent the same, the inside function the same. We leave it all the same, all itself. You can quadruple parentheses it. Now we multiply by the derivative of the tangent function. Hello. Which will be the secant squared function, I think. Yeah. The secant squared function. And that's pretty much your answer. I mean, you could probably go with secant over tangent, or maybe law. Yeah, these are the way I don't like, because maybe you'll see your answer like, or maybe your textbook will have it like cosine of x over sine of x. No, sine over cosine, right? Multiplied by 1 over the cosine squared of x. And you'll have sine of x over cosine cubed of x. I don't know, but it doesn't matter. They're both the same. I just left it like this in my answer. Make sure you talk to your teacher, or make sure you like touch base on what type of answers they want, because some professors are really weird with that. Okay, next one. I'm gonna erase all this. Wow, that'll work out. And next we got f of x, same thing, y, this is y, 3x minus 2x squared to the third. Okay, so the outside function is a cube one, the inside function is this. So if I want to find f prime of x, take the derivative of the cube function, 3 times 3x minus 2x squared. I usually don't write my 2's like this, but it's hard with this pen. Let me write my 2's the cool way. 2x squared. Yeah. Parentheses again, remember, I'm obsessed with parentheses. I would marry them if they were like, you know, they like me back. But so the derivative of this, that was weird. The derivative of 3x minus 2x squared is 3 minus 4x. And you know what? Just box it, and let's not waste time with the multiplying out. So as you guys can tell, you have to be sure that you know your power rule. And you're going to need to know your quotient rule, as we're going to see in just a couple examples. But if you have your power rule, other derivative rules down, the chain rule is pretty quick. No, the chain rule is gonna make a lot more sense. It's gonna become easy once you do a lot of practice problems. I keep forgetting my camera's in there. It's usually somewhere else, or it's usually more in the back. Hold on a second. What did I do? Oh, I forgot to put the second power here. 3, yeah. 3 times. And I'm not expanding that. That's like next level stuff. Yeah, leave it like that. Yeah, forgot that power. My bad. Oh, I did that actually to make sure you guys, I want to see if something can call me out and catch that before I catch them. All right, let's look at a different one. Okay, here's a cool one. This is a good one to see. So let's say we have y equals negative 7 over 2t minus 3 squared, or minus 2, 3, all to the second power. Let me make this a little clear. So the negative, I think I'm writing bigger than I need to, but whatever. Now, I don't like the quotient rule. I just don't. So this is an opportunity to not use it, because you can actually rewrite this as negative 7 times 2t minus 3 to the negative 2. Same thing. You don't have to worry about the quotient rule. Hey. And now let's look at this as the inside, the red. Inside the red function, the outside to everything else. So now we differentiate. Y prime is negative 2 times negative 7, 14. Keep this all the same. 2t minus 3, negative 2 minus 1 to the negative 3. So this times the derivative of 2t minus 3. The derivative of 2t minus 3 is just 2. Check that. Check that stuff out. Yeah, and then you drop this to the denominator, multiply by 2, so it's going to be 28. 2 times 14, 28. All over 2t minus 3 to the third. And no quotient rule is needed. Maybe I was traumatized by the quotient rule as a kid because I think I missed an A. I think I might miss a perfect score by like 1 point because I messed something up with the quotient rule. I'll never forget that. Okay, let's do like a couple more. Do 2 more of these. 2 more of these will be good to see. All right. 2 more for now, because I'm actually thirsty, and I have some chocolate milk right there. Where am I? Okay, so we're at H. Y equals x squared times the square root of 1 minus x squared. So again, use the power rule, or you rewrite this. I would rewrite this as x squared times 1 minus x squared all to the 1/2 power. Now this is like a combination quotient rule, or like product rule, and there's a product rule and chain rule together. So 3 colors. So we have this right here in red, and this is our other function. So we have this function, that's 1, the quotient, the square root function, and the blue function on the inside. We got 3 functions here. So if we want to take the derivative here, we're going to have y prime equals the derivative of x squared, 2x. Leave all this stuff as is, because we're using the product rule right now. If you need to, let me show you the product rule again. If you want to find the derivative of f times g, that'll be the derivative of f times g plus f times the derivative of g. So it's like red, that sort of thing. If you need a refresher. Okay, so I did the first part. I did the fg, or I did the f prime g. Now I added 2, keeping the red function, or the f function as it is. Now I multiply by the derivative of this. Now, this is chain rule, because I gotta take the derivative of the outside, which is the black one, 1/2 times 1 minus x squared to the negative 1/2. Because remember, chain rule, I keep this derivative, I keep this the same, and I use the power rule. And now I multiply this by the derivative, by the derivative of 1 minus x squared, which will be minus 2x. And close the brackets and parentheses. See, that's why parentheses are great. Okay, let me go to the next line below. And we get y prime will be, I think you're probably gonna want, this is just gonna be some like rationalization or making the common denominators, but this is pretty much done. Okay, so this is on the bottom, that cancels. Plus, so we have an x on top. So what's going on here? So this is in the bottom. So 1 minus x squared to the 1/2 minus x squared times an x minus x cubed, right? Let me step back to make sure I didn't screw up something. Okay, yeah, it looks good so far. I mean, okay, yeah, I know what they're just gonna make, and they're probably in their textbook, they're gonna have these combined with like denominator. So, I mean, this would be like, you would multiply this by, I mean, should I show you? I guess. You're gonna multiply this by, and you all see that. You're gonna multiply this by 1, which is 1 minus x squared. Let me just do it, because you're gonna see it in your textbook and it can be kind of confusing. So 1 minus x squared to the 1/2 over 1 minus x squared to the 1/2. So you're multiplying this by that, which is then going to be on top of 2x times 1 minus x squared to the 1/2. Don't cancel those out because it's going to run everything. Then we go minus. Now, since it has a common denominator, we could just straight up subtract the x cubed on top, keep that on top together. And I'm still there. These are the same, so this will just be 1 minus x squared to the 1 power, so just to the 1 times 2x minus x cubed all over 1 minus x squared to the 1/2. And you go 2x minus 2x cubed. Oh, this, yeah, they're gonna want even further. They're gonna have 2x. So let's go up here. 2x minus 2x cubed minus x cubed That's going to be on top, all over the 1 minus x squared to the 1/2. I don't really like giving these tests because this is just really testing your rationalization. So hopefully your teacher doesn't do that either. But it'll just be 2x minus 3x cubed on top over 1 minus x squared to the 1/2. But this is no longer calculus, so I wouldn't. Hopefully they don't make you waste your time with that. Yeah. And they may even have the bottom as a square root, but no big deal. All right, and maybe let's see if should I show you one more? Yeah, let me show you one more. One more that. Let me drink some milk. That I told you I have milk. Raisins. Come on. All right. So the final one, 5. We have y equals x over the cube root of x squared plus 4. And again, avoid the quotient rule because the quotient rule is evil. So we're going to have x times x squared plus 4 to the 1/3 power. It's the same thing. And so we have product rule again. Yeah. So we have one derivative here, or we have one function here. We have another function in the black. And let's put this as blue, x squared plus 4. So we have 3 functions again. Like the one we did, I think the one we just did. So let's see if we can do it. Let's see if you can do it. I can do it. I mean, I hope I can. Take the derivative of x. That's just 1. Leave all this stuff the same. Leave all this shite the same. Let it be, let it be. Plus, now leave the x squared as is. Now open the super parentheses brackets. Multiply by the derivative of this whole thing. The power rule, 1/3 times x squared plus 4 on the inside, so the negative 2/3. Keeping this for now the same, but now we multiply it by the derivative of x squared plus 4, which is 2x. Now the rest is just the tedious compilation combining. So x squared plus 4 to the 1/3 power. Plus on top we're going to have 2x squared all over 3, hold on. 3 times x squared plus 4 to the 2/3 power. Yeah. And make like denominators, so multiply this by, we're going to multiply this by 3x squared plus 4 to the 2/3 over 3 times x squared plus 4 to the 2/3, right? So they're both then going to be over 3 times x squared plus 4 over to the 2/3 power. So for the sake of time, we're going to get, this will be multiplied by 3 times x squared plus 4 to the 2/3 power times x squared plus 4 to the 1/3. You can combine them all together now because they're going to have a like denominator plus 2x squared all over. They're all going to be 3x squared plus 4 to 2/3. These combined, they just be x. Oh, okay, I know what they're trying to show here. These mother truckers are cool. This is actually a cool one, sort of. This becomes equal to the 1 power. There's 2/3 plus 1/3 is 1, plus 2x squared all over 3 times x squared plus 4 to 2/3. So 3x squared plus 4 plus 12. Going back up here, 3x squared plus 2x squared. So we're going to have 5x squared plus 12 on top. All over, hold on, 3x squared plus 12. Yeah, 3x squared plus 12. 3 times x squared plus 4, so 2/3. Wow, what a problem. What do you think about that, Odie? Yeah, I hope you guys don't have a teacher that makes you have these types of problems in your test. Maybe it's just good to practice that because to make sure you get the right answer without getting lucky. But yeah. So I hope that helps. I'm going to try to do some more harder ones, but really practice chain rule, practice it over and over because this is the hardest derivative rule. Implicit differentiation, related rates, all is based on this. So once you master this, the rest is actually not that bad. It's actually easy, but you have to master this. Is that right? Isn't that right, Odie? Yes, it is. All right. I hope that helps. Let me know if you have any questions in the comment section. Please subscribe and like and tell me how great I am, or just tell me how bad I am and give me feedback. Help me out. Thanks, guys.